So remember in our last notes, we went over polynomial long division. And we talked about how that was one type of polynomial division. We actually have a second type, and it is called synthetic division. Now, the thing about the synthetic division is that it is faster because it's kind of a shorthand of long division. However, there are two catches with that. So because it is faster, it is a little bit easier to make mistakes with that. And then also, we can only use synthetic division in specific cases. So in order to be able to use synthetic division, your divisor must be of the form x plus or minus some number or constant r. So that means that in some cases when it's not of that form, meaning that if I have something that isn't a degree of 1, so if I'm dividing by something like x squared or some other exponent, we have to use long division. So that's why we need to know how to use long division, because long division will work in every single case. Synthetic division only works in some cases. Now, there are a couple of differences with our synthetic division. We are just going to be looking at the coefficients of our numbers. They still need to be in descending order, and we still need to make sure that we have all of our terms present. And then on the outside, we're going to write our r, but notice that the r is actually the opposite sign of the divisor. So we're dividing by x minus r, and I'm just going to put an r on the outside. Then because we've already switched that sign, instead of subtracting as we go down, we're going to add as we go down. And those are really going to be the biggest two differences. And I'll go ahead and show you an example, because I think that makes a little bit more sense when trying to look at the steps than looking at all of those words. So it says use synthetic division to do the division problem. So again, we still want to make sure that our terms are all present and that we are in descending order. So we do need to be careful about that. But if I check, both of those are good to go. So when we write our division bar, it's actually going to be upside down from what it normally looks like. So we're going to write 2 negative 13, 26, and negative 24. Then on the outside, we're going to write the opposite of our constant of our divisor. So we're going to write 4. Now, our first step is always going to be to bring down that first constant term. So in this case, that's the 2. Our next step is going to be to multiply to get that next term. So I have 4 times 2, which gives us 8. And then as we go down, we're going to add. So I have negative 13 plus 8 is going to give us negative 5. And then basically we're going to continue with that process. So 4 times negative 5 is going to give us negative 20. Negative 20 plus 26 is going to give us a positive 6. 6 times 4 is going to give us a positive 24. And negative 24 plus 24 is 0. Now this last number I'm always going to box off because it's always going to be our remainder. So in this case, our remainder is 0. Then the next number over is always going to be our constant. Then the next is our x, then our x squared. And we would continue in a similar pattern if we had any more numbers. In this case, we don't. So we can write our answer as 2x squared minus 5x plus 6. So those numbers that we get as our answer become the coefficients of each of our terms. So let's look at another example. Again, I'm going to set it up the same way. My 2, 3, -4, and 15 go on the inside. This time, though, I need to flip that sign, so I get a -3 on the outside instead. I bring down my 2, and then I start my process. -3 times 2 gives us -6. 3 plus -6 gives us -3. -3 times -3 is going to give us a positive 9. 9 plus -4 is going to give us 5. 5 times a -3 gives us -15. -15 plus 15 gives us 0. So the same way, 0 is going to be our remainder. Again, this is going to be our constant, x squared. So we get 2x squared minus 3x plus 5 as our final answer. All right, let's look at one more example. We have a couple of things going on in this example. Notice, first off, we have a 4th degree. So it's a little bit different than what we've been doing, but that's okay. We can handle that. And then the other thing is, notice that we have a leading coefficient on our divisor of 2. And so as of right now, we cannot do our synthetic division the way that we've been doing it. However, whenever we have something that's not a 1st degree, like we're dividing by x squared, there's not a way around that. You cannot use synthetic division. But when we have our leading coefficient is not 1, we can get around that. So I'm going to go ahead and rewrite this as division. Instead of using the division symbol, I'm going to rewrite it as a fraction. Now, I need that leading coefficient of our denominator or our divisor to be 1. So notice that if I were to multiply this by 1/2, it would do that. 2 times 1/2 gives me 1. I would change my leading coefficient to 1. But if I do that to the bottom, I must also do that to the top, because now I have 1/2 divided by 1/2, which is really just 1. So I didn't change the actual values of my fraction. I'm just changing the way it looks. So notice that this would become 4x to the 4th minus 2x squared plus 1/2 x plus 2 divided by x plus 1/2. So we're going to set up our synthetic division the same way. I'm going to put my 4, but be careful because notice that we have skipped our 3rd term, which means that we have to put a placeholder of 0 there. Then we have -2, 1/2, and 2. And now remember that on the outside, I'm going to write the opposite of our constant, which is 1/2. So we put -1/2. And then we just start our process. Now we have a fraction. That's okay. It doesn't change this process. So I bring down my 4. -1/2 times 4 is going to give us -2. -2 plus 0 is still just -2. -1/2 times -2 is going to be a +1. -2 plus 1 is a -1. -1/2 times -1 is going to be a +1/2. 1/2 plus 1/2 is going to be 1. Then we get -1/2. And then -1/2 plus 2 is going to be 1 1/2 or 3/2. And remember that that is always going to be our remainder. Then we're going to rewrite. So remember, this is our constant, x squared, x to the 3rd. So we get 4x to the 3rd minus 2x squared minus x plus 1. And then we're going to have plus 3/2 divided by x plus 1/2. Now, the only thing is we don't want to leave that last part as a fraction within a fraction, because it's just not a great notation. So basically, we're going to undo what we did before, where when we multiplied by 1/2 to the top and bottom, now we're going to multiply by 2 to the top and bottom, because that's going to basically undo those fractions that we have there. So the first part is still going to stay the same. And then we would have 3/2 times 2 is going to give us 3. And then we would have 2x plus 1 in our denominator. And so that's going to be our final answer. So remember that we always need to check and make sure that we have all of our terms present and that we're in descending order. And then remember, we actually need to take it one step farther. We have to make sure that our divisor has a leading coefficient of 1 and a degree of 1 in order to be able to use our synthetic division. Otherwise, we have to use our long division.